All right, this is the Unit 2 Honors Test Review. Just a couple of reminders. You can stop the video and rewind it until you get it down, what you need to know. Also, I would suggest that after you go over this, you do every problem a couple of times until you can do it completely by yourself. And then also, I'm only doing a selected number, usually the odds on most of them. So you're going to have to do the others on your own. But this will give you a good idea on most of them. I will be going fast because I don't want to make this a long video, but remember you can stop it and rewind it and look at it again. Okay, so the first problem, 9x squared minus 1, this is a review from last unit. This is special kind of factoring. This is a difference of two squares. Take the square root of 9x squared and you get 3x, and that goes in the first slot in each binomial. And the square root of 1 is 1, and that goes in the last slot, and one's minus and one's plus. So 3x minus 1, 3x plus 1. The next problem, number 3, this one is a special type of factoring called a difference of two cubes, and we have a formula, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Also, your other problem, number 4 on here, is a sum of two cubes, and that's going to be a plus b, a squared minus ab plus b squared. Just remember that the signs change a little bit. But all we have to do is find the cube root of 8x cubed, which is 2x, and the cube root of 27, which is 3. And this is a, 2x is a, and 3 is b. So when we plug this in here, we're going to go back up to our a minus b, which is going to be 2x minus 3. Then I have to do a squared, which is 2x times 2x, which is 4x squared, plus a times b, which is 2x times 3, which is 6x, and b squared, which is 3 times 3, and that's 9. So that is difference of two cubes factored. Problem number 5, you're asked to simplify by factoring. We know that top is going to, that trinomial on the top is going to factor to be two binomials. I could probably pretty much guess that my divisor, x plus 7, is going to be one of those binomials. So this makes it a little bit easier. So I know that to get this 7x squared that I'm circling, I know I got to times two numbers together to get 7x squared. Well, I know 1 times 7 is it. So 1x, which I put right here, which we already have an x plus 7, times 7x would give me 7x squared. I also know to get the last number in this trinomial, I got to multiply the last numbers together. 7 times whatever number goes right here. Well, I know 7 times 4 is 28. I also know that those are both plus, so these are both plus right here. And so that probably is my other binomial, but I can check by multiplying the two outer numbers together. That's going to give me 4x. And the two inner numbers together, that's going to give me 49x. Add those together, I get 53x, which is the middle term over here. So that is the correct factorization. All I need to do now is cancel out the x plus 7's, and my answer is 7x plus 4. Okay, the next one on here is number 7, which is they want you to use synthetic division. In using synthetic division, I'm going to scroll this up a little bit. In using synthetic division, we have that upside down division bar, I guess you could call it. I take the opposite of that number right there, 2, and I get the root, which is -2, remember, put it on the outside. I use the coefficients, which are 1 in front of the x cubed, 13 negative 12, and negative 8. I put them right there, and I bring down the first number right there, 1, and I've set it up. And then I multiply as such. Negative 2 times this 1 down here is negative 2, and I put it under the next number. 13 minus 2, so I add or subtract in this case. I get 11. Then I multiply negative 2 times 11 and get negative 22. I add those together and I get negative 34. And then I multiply negative 2 times negative 34 and I get a positive 68. I add those together and I get a positive 60 for my remainder. So if you remember right, these numbers down here, 1, 11, negative 34, and 60, are the coefficients for my new polynomial. I just divided an x to the first up here, right here, into an x cubed. That reduces it to an x squared. So this number 1 right here is the coefficient for the x squared term, which is 1 less than x cubed up here, because I just divided an x1 into x cubed, I get x squared. Then I just go in descending order. The 11 is for the x term. The negative 34 is my constant, and 60 is my remainder, and I put it over the divisor, x plus 2. And there is my answer for synthetic division. Okay, number 9. This one I am supposed to use long division on. So, as I do this one right here, I am going to make a division bar. I have my divisor, 4x plus 1 out here. And my dividend is 4x cubed plus 5x squared minus 3x plus 1. And so this is what I'm going to do. I need to ask myself, what do I times this first number here to get this first number here? 4x times what will give me 4x cubed? And the answer is x squared. I then multiply x squared by my divisor, 4x plus 1. So I got to distribute it. X squared times 4x is 4x cubed, and x squared times 1 is x squared. And then I have to subtract. And I've told you that changing the signs and adding is the same thing as subtract. So the first ones are going to add up to 0. 5x squared minus x squared will give me 4x squared. I bring down the negative 3x right there. Then I repeat the process. I go back up to my divisor. What do I times 4x by up here to get this 4x squared right down here? And the answer is x. X times 4x is 4x squared. X times 1 is x. And then I change the signs and add, which is the same thing as subtracting. And so this gives me negative 4x right here. Bring down the 1. I will repeat the process again. What times is 4x by up here to get negative 4x? The answer is negative 1. Negative 1 times 4x is negative 4x. Negative 1 times 1 is negative 1. Change the signs and add. I get 2 right there. And so my remainder is 2. So I get x squared plus x minus 1 plus 2 over 4x plus 1 is my answer. Okay, the next problem. Number 11. We want to multiply and simplify. So we can write these factors if we'd like. And I am going to I'm gonna change 52. 52 will break down into 2 times 26, and 26 will break down into 2 times 13. So I'm going to change 52 to 2 times 2 times 13. The x squared as x times x, and the y as y. And then on the bottom right here, x squared minus 81 is a difference of two squares. It factors to be x minus 9 times x plus 9. So I'm just completely factoring everything so I can cancel out factors. 3x minus 27, I can factor out a greatest common factor of 3. That leaves me with x minus 9. And down here, 13 is prime number. I can write x cubed as x times x times x, and y squared is y times y. And now I'm ready to cancel. Any factor on the top that's the same as a factor on the bottom can cancel. Like I can cancel this x minus 9 with this x minus 9. I can cancel this 13 with this 13. I can cancel this x with this x, and this x with this x. I can cancel this y, and I think I've got everything. So I'm going to multiply everything left on the top. I have a 2 times a 2 times a 3, which makes 12. And I have an x minus 9 and a y. So it's going to be y times x. I said x minus 9, x plus 9. And that is my answer. Oh, and I have an x. I missed this x right here. X times y times x plus 9. All right. Number 13. A division problem is the same thing as a multiplication problem. You just got to change this to times, put a dot for times, and take the reciprocal of the second fraction, if you remember right. So I'm going to start off by taking the reciprocal over there and making this a times. I'm going to put the 3x plus 3 on top, but I'm going to factor out a 3. So 3 times x plus 1. X minus 2 is not factorable. We put that on the bottom. Over on the left side, I know that x squared plus 2x minus 8 is going to factor into two binomials if it factors. I'm looking for two numbers I can times together and get negative 8. So when I add them together, I get 2. And that would be x plus 4 times x minus 2. And on the bottom, I'm looking for two numbers I can times together and get 3, and add together and get 4. And that would be x plus 3 times x plus 1. So I'm ready to cancel. I have x plus 1s that will cancel right here. I have x minus 2s that will cancel right here. And I think that's it. So I have on the top, I have this 3 over here times this x plus 4. So 3 times x plus 4 over x plus 3. And that is my answer. Okay, number 15. Number 15 asks us to add or subtract and then simplify completely. So on this one right here, I have to get a common denominator. You know, I could, if I completely factor 16x, I'm going to completely factor each of these. 16 breaks down to 2 times 2 times 2 times 2. And then, of course, I have an x. And over here, 4x squared breaks down to 2 times 2 times x times x. Well, I take every factor I see, the most number of times it occurs in a factor. Well, I see that 2 happens, and it happens 4 times here and 2 times there, but I got to take the most number of times it happens, which is 4. So 2 to the 4th power. I have an x here and 2 x's there. I got to take it the most number of times it happens, which is twice. It happens x squared times. And so 2 to the 4th is 16. X squared would be my least common denominator. So there's some of you guys can get that just by looking at them. But if you need to break them down, go ahead. So 16x squared is my least common denominator. So I rewrite my fractions over here. So I have my common denominator, 16x squared. And I noticed that I have this first fraction over here it has 16x, and it needs to multiply by another x. So I'm going to times the bottom by x, which means I have to times the top by x, because this is a special 1. If you remember, right? X divided by x is 1. So x times 6 on the top is 6x. So over here, on the right fraction, what did I multiply 4x squared by to get 16x squared? Well, I multiplied it by 4. So if I'm going to multiply the bottom by 4, I got to multiply the top by 4. That's my special 1. 1 times 4 is 4. Now I have two fractions with common denominators I can add together. Since 6x and 4 are not like terms, I can just write it as 6x plus 4 all over the common denominator, 16x squared. I do notice that I can factor a 2 out of the top. If I do that, I get 3x plus 2. And then I can change 16 to 2 times 8x squared. And the 2's cancel out, so my answer is 3x plus 2 over 8x squared. Number 17, subtraction is like addition. I just got to get a common denominator to add these together, but then I subtract the numerators. Once again, I factor completely each of these denominators. X squared minus 4 is a difference of 2 squares, so it factors to be x plus 2, x minus 2. And of course, the other fraction, the denominator is x plus 2, which is not factorable. We can, all we have to do, so we know we have to take each factor that occurs, which is x plus 2 and x minus 2. So I have x plus 2 times x minus 2 as my common denominator. And I notice that the one on the right is missing x minus 2. So I'm going to multiply the top and bottom by x minus 2. That's my special 1. Okay, so my first fraction had the common denominator already, so I just leave the 1 there. My second fraction, I'm going to multiply, and really this is a minus problem, so I'm going to change this minus to a plus and make that negative. Remember, it's the same thing as changing, like when we subtract and change a minus sign to a plus and change the signs. So I've got to distribute this negative x through. So negative x times x is negative x squared. Change that now. And negative x times negative 2 is positive 2x. So if I add the 1 to it, I get negative x squared plus 2x plus 1 all over x plus 2 times x minus 2. Now I have a feeling that the top will factor, and I can cancel some factors. So I am going to factor a negative 1 out of the top to change my sign so my x squared is positive. That gives me x squared. It's going to change all the signs, minus 2x minus 1. And so now I'm going to factor the top. I'm going to put it right down here. I have the negative 1 outside, and I have my two binomials. And I can see that, let's see if this factors. Negative 1 times negative 1. Negative 1 times positive 1 is negative 1, but those do not add up to negative 2, so this is not factorable. So that is my answer. I can just leave it like this. Okay, problem 19. This one, we are solving an equation. So solving an equation, a rational equation, we also have to find the least common denominator. Well, I only have one denominator, and that is x. These denominators each have a denominator of 1. 1 times x is x. So when you're solving a rational equation, you find the least common denominator, and you just multiply both sides by that common denominator. So I'm going to multiply this one by x, and I got to multiply this whole side by x, so I'm going to distribute it. So it's going to end up timesing this term by x and that term by x. Over here, my denominators disappear because I can cancel out the x's, and I get 6. And then over here, I get x times x, which is x squared, and negative 5 times x is negative 5x. This is a quadratic equation. I got a minus 6 from both sides. That's going to give me 0 equals x squared minus 5x minus 6. And this factors to be x minus 6 times x plus 1, because negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. Therefore, my two solutions are x equals 6 and x equals negative 1. And I got to check to see if any of those are extraneous. I only have one denominator up here. If I put 6 in for x or negative 1 in for x, it doesn't make it into the denominator 0. So those are, neither one of those are extraneous solutions. So those are the solutions to the problem. I'm also going to help you out with number 20, solving this rational equation. Looks like a doozy, but it's not too bad. The reason I say that is because, you know, x minus 2 and x plus 4 are not factorable, but this middle trinomial is factorable. It factors to be x plus 4 and x minus 2, because 4 times negative 2 is negative 8, and 4 plus negative 2 is 2. So it factors to be those. Well, I notice that I have this x minus 2 over here, and there's one right here in the middle here. I have this x plus 4 over here, and there's this one in the middle. So my common denominator is x plus 4 times x minus 2. So if I multiply each side by x plus 4 times x minus 2, I'll do it here again, x plus 4, x minus 2, and x plus 4, x minus 2. So I've multiplied both sides by it. I had to distribute it on the right side to both fractions. I notice right here on the left side, the x minus 2's cancel out, and I have x plus 4 times 1 left, which is just x plus 4. In the middle, so we already rewrote that as x plus 4, x minus 2. In the middle, this x plus cancels with that x plus 4, this x minus 2 cancels with that x minus 2, and I'm just left with a 2x plus 1. Everything cancel. And on the very right fraction, the x plus 4's cancel out. I distribute the 2 to the x minus 2, and I get 2x minus 4. And I have a linear equation. If I combine like terms on the right side, I have 4x minus 3. I am going to get the x's to the right side. I'm going to minus x from both sides. Get the constants to the left side, so I'm going to add 3 to both sides. I'm going to get 7 equals 3x. Divide both sides by 3. Get x equals 7/3. I hope I did that all right. I think I did. Okay, so if I check for extraneous solutions, you know what? All I have to do is check the x minus 2 and x plus 4. Neither one of them are going to make 0, so 7/3 is not extraneous. That is the answer. Okay, number 21, one of these work problems, we call them. Andrew can wash the windows on their house in 30 minutes, and Jeff can wash the windows in their house in 40 minutes. How long will it take them to wash the windows if they work together? So, remember, in this kind of a problem right here, it's pretty simple. If Andrew can do it in 30 minutes, he can do 1/30th of a job in a minute. And Jeff can do the window in 40 minutes, so he can do 1/40th in a minute. And together, they can do 1/x in a minute. And we just set up the equation that way. And we solve that equation. I can see that my least common denominator, if I look to see what the smallest number that 30 and 40 go into, it's going to be 120, I believe. So I can times both sides by 120x. 120x, 120x, solving a rational equation. So 30 will go into 120, 40 times x times 1 is 40x. 40 will go into 120, 3 times, I said that wrong over here. 30 will go into 124 times. 4 times x times 1 is 4x. Over here, 40 will go into 123 times. 1 times 3 times x is 3x. And x's cancel out, and 1 times 120 is 120. 4x plus 3x is 7x. Divide by 7. And whatever that is, I don't have a calculator on me. 120 divided by 7. And then you can change it to, that's going to be minutes. So here, let me grab a calculator real fast. $120 divided by 7 is 17.14. And then we can times the 0.14 by 60. And that's going to give me 8.4 minutes. So we're going to say 17 minutes and 8 seconds. We'll round it to the nearest second. 17 minutes and 8 seconds. They can do it together. That's a work problem. Okay, number 23. We need to identify the intercepts and the asymptotes of this function. Okay, first of all, to find an x-intercept, you set the numerator equal to 0. Well, x squared minus 9 factors bx minus 3 times x plus 3. I could have also added 9 to both sides and taken the square root of both sides, but my two solutions are 3 and negative 3. So this is where it crosses the x-axis at 3 and negative 3. And then on the bottom, okay, and then, my y-intercept I obtained by putting 0 in for x. So if I put a 0 in for that x, a 0 in for that x, a 0 in for that x, all I'm left with is negative 9 over negative 8, because everything else is 0, which is 9/8 or 1 1/8. So my y-intercept is 1 1/8. That's my y-intercept. That's where it's going to cross the y-axis. Okay, to get my horizontal asymptote, all I need to do is check the degree of the numerator and compare it to the degree of the denominator. Well, they're both 2, and when they're the same, you take the coefficients and divide them. Well, the coefficients are 1 divided by 1, which is 1, so y equals 1 is my horizontal asymptote. I'm going to put HA for horizontal asymptote. To get my vertical asymptotes, I set the denominator equal to 0. I want to know what makes it 0, because if you divide by 0, it's undefined, and so my vertical asymptotes happen where the graph is undefined. So if I factor this, I know that x minus 4 times x plus 2 is going to give me that, and set that equal to 0. And so my solutions are x equals 4 and x equals negative 2. Those are going to be my vertical asymptotes. And I think I'm done with that problem. Find the asymptotes and the intercepts and the asymptotes. Okay, number 25. Number 25, I made a graph of it too. I'm just looking on here. It says, given the graph of the rational expression, state the domain of each graph. Well, I can see that there is a vertical asymptote right here. And I can see that there is a vertical asymptote right here. And I'm just naming the domain of this graph. I know that this function takes on all numbers for x except for where it's undefined, and that's where the vertical asymptotes are. And so negative 3 and positive 3 is where it's undefined. So my answer is all reals, x is not 3, and x is not negative 3. So all real numbers except for 3 and negative 3. Now on the test, we might have written it as the domain as negative infinity to negative 3, negative 3 to 3, and then 3 to positive infinity, like that. I might have written it like that. So you got to know interval notation as well as that other way. Number 27, we are solving this radical equation. This is actually a pretty simple one because they have a single square root on both sides. All we have to do to get rid of the square root is square both sides, and that gives us negative 3 minus 4x equals negative 2 minus 2x. And so I get to solve that linear equation. I just am running out of time right now, the bell rang, so I am going to let you solve that linear equation. On this one right here, we are going to have to square both sides, but on the right side it's going to be a little bit different. Left side, the radical just goes away. On the right side, I'm multiplying this by itself twice. And so I've got to multiply 2x plus, I got to distribute 2x plus, the square root of 2x plus 15 times the square root of 2x plus 15 is just 2x plus 15. And then the square root of 2x plus 15 times negative 2 is negative 2 root 2x plus 15. Negative 2 times square root of 2x plus 15 is negative 2 root 2x plus 15. And negative 2 times negative 2 is positive 4. And then I've got, oh, I've got my equal sign right here. Oh, wait, no, my equal sign's over here. 2x minus 1. Sorry. And then over here, I'm going to get everything to the other side. So I'm going to minus this 2x from that 2x, and that gives me negative 1. Plus, and I'm going to add the 15 and the 4 together to get 19. So I'm kind of in a hurry, sorry. 19, and then a minus 4 square root of 2x plus 15. It's 4 because negative 2 and negative 2 make negative 4. Then I'm going to minus 19 from both sides. That gives me negative 20 equals negative 4 times the square root of 2x plus 15. Then I'm going to divide by negative 4. That gives me 5 equals the square root of 2x plus 15. Then I square both sides. That gives me 25 equals 2x plus 15. Then I just solve that linear equation, and I need to check for extraneous solutions. That's going to give me x equals 5. And I need to check to see if x5 is extraneous, see if it makes it not true. 2 times 5 is 10, minus 1 is 9, square root of 9 is 3, so the left side is 3. 2 times 5 is 10, plus 15 is 25, square root of 25 is 5, minus 2 is 3, so it makes them both equal, so we're all good.